quick, get your homework started on this. As you are taking a look, we're going to explain the definition of a function. So yesterday, that video and kind of looking at it, keeping in mind what is a function when we are looking at that. A function is when we have all the sets of, and when we are looking at that, sets of inputs and outputs. And a lot of times when we are looking at those outputs are our y values. Okay. Function is a special type of in this case, we're looking at a relation. So a special type of a relation. In a function, when we look at that, input has exactly one yesterday output. When we talk about our domain, that's the list of all of our possible inputs, and our range yesterday, as we were filling in our notes, was our outputs. With that, I would like you to add that when we talk about our inputs, that's our x. When we talk about our outputs, that's our y. So again, with the domain is oftentimes associated with our x values. And our range is going to be our y values that we have in our problem. Okay? Unique output. 4 has 7, and then 4 has -5. Can this be a function? No, not a function when we are taking a look at this one. And the reason would be that both 4 has 2 outputs, right? What are the 2 outputs for 4? One was 7 and -5. And we also notice that 2 has 2 outputs. The 2 outputs for 2 happen to be 6 and -4. Okay? So if we're looking at this one, we look at our inputs first. So when you explain, this would be your explanation part. The reason that it's not a function, 4 has 2 outputs, 2 had 2 outputs. As we look at this one, -1, 0, 1, and 2, we have very unique inputs. So is this a function? Does each input have an output? Yes. Does it matter that these 2 outputs are both -1? No. Our explanation is going to be each input has 1 output. So when you do your homework, you want to get used to writing that. So you should be writing that. When we are taking a look at this next one going down, I want you to look at these next 2 and just do the yes or no part. Do you think it is a function? Yes or no? And then we'll look at your explanation at that. Raise your hand if you think no. No for the first one. No, it's not a function. Some of you wrote no. Each input, -5, -4, -3, -2, have 1 output. So when we are looking at that first one, we should be putting that this should be yes, it is a function. Each input has an output. When we take a look at the second one, we have 0, 3, 6, 9, definitely 4 different inputs. Each input has 1 output. So the key thing when we look at a function, when you put in 1 number, you can only get out 1 number. It does not matter if you put in 1 and you get 5, and you put in 2 and you get 5, you get the same number. Each input can only have 1 output. So like that first one where we had a no because 4, when we input it, gave a 7, and the second time it gave us -5. So as you turn to the top of the next page, we also talk about what's to determine if something is a function, that it passes what's called the vertical line test. So it says determine if the following graphs are functions. Remember, for each input, you have to have 1 output. So remember, our inputs, if we are looking at those, anytime we look at our inputs are our x, right? So when we look at this, our input is the x. For each input that I put in, do I have only 1 output as I look at this graph? No. Which one do I have more than 1 output for on that first graph? Okay, and when I go to 4, I get 4. When I go to 4, do I get a different number? From that line, I only get 4, right? So when I am looking at this, so when I look at that second graph, at 0 I get 9 for my input. But what happens at 3? At 3, I could have 3. I could have 4. I could have 3.5. I could have 4.1, 4.3. All of these values for an input of 3 are going to be my output. So because there are many values on this vertical line, is this one going to be a function? We would say, no, this one is not a function. And here is what I would like for you to write down as you are looking at that. The reason that this one is not a function, each x-coordinate there is more than one output y. For the input of 3, you could have an output of 3, you could have an output of 6, you could have an output of any number in between 3 and 6. So because of this, all along here, that means it is not a function. So it says, can we think of a shortcut for checking if a graph is not a function? What kind of a line is this right here that goes across, up and down? Vertical, whereas here it's horizontal. Are horizontal lines going to be functions? Yes. Are vertical lines going to be functions? Definitely not. So when we're thinking of a shortcut that we can think of, I know it's kind of long what they had, but it says, look at the points that have the same x-coordinate. And the key thing is, if the points are located on a vertical line, so anytime the points are located on a vertical line, it is not a function. Vertical line, not a function. It doesn't matter where that vertical line is, anytime I have a vertical line, which is when I think of my equations, an undefined slope, as an equation where x equals a number. Anytime I have that, it will be not a function. So vertical line, not a function, is the key thing I want you to put down there. So some of you haven't written anything yet, so I'll pause this. You don't function. In the first one, look at your inputs, all your x values. Do you have any that are the same? Yes. So, is it a function? Yes, it's a function. Why? Each input has, our reason is, each input has what?
Has one output.
One output. Start ready. So, take a look at all your tables and your lists of numbers and think of that. Do the yes and no. I want you to do that right now. And for this one, think if you draw a vertical line, will it pass the vertical line test? If I draw a vertical line right here, it only goes through one point. What happens if I draw a vertical line at -2? How many points does it go through? 2 points. That means -2 has 2 outputs. Is this a function? Not a function. Please write that down, Wyatt. So not a function, and our reason is going to be because there are 2 outputs for x equals -2. The 2 outputs are up at 2, it looks like, and down at -2. So if I'm looking at the next table here, as I look at that table, Joe, would you say this table function or not a function?
Yes.
Function. Each input has one output. If we look at this table, as we are looking at this table, Cameron, what are you thinking? Function or not a function? So when I look and I have -2, it gives me -7, and -2 gives me 5. And 2 gives me 0, and 2 gives me 6. So not a function. And our reason would be, you want to make sure that you could easily tell me in this case, if we are giving our reason is going to be because -2 has 2 outputs, right? The other thing, besides -2 have 2 outputs, 2 has 2 outputs. So very specific when you are telling that. So Olivia, if we are looking at that next one, is it a function? Not a function. Because, right, what one?
Positive 2 has 2 numbers.
So I have 2, 7, and I also have 2, -1. So we're always looking at the x value to help us try and decide. Nice job on that. Not a function, because 2 has an output of -1 and 7. If they would have both been -1 with 2, or they would have both been 7, it would work. But because we have 2 different ones, not a function. So you just got to be really careful as you function. Rules can be written for any function. Some rules are more complex than others. A rule for a function can be written in a sentence form, or we can write it using numbers and variables. If we are writing an equation, anytime you are looking at an equation must have an equal sign, okay? So anytime you look at that word equation, it must have an equal. That's the verb in your sentence, okay? So when we are thinking about that. So it says, find an equation that you're going to write. You're going to have to decide, is it linear? And how do you write linear equations? So in this first one, when we look at our table, notice on the table that they have the change in our output, what letter is this up here above the output? Y. Above the input, please write X, okay? So how do we find the slope? We find the slope by taking the change in Y divided by the change in X. Now, if we look at these values, it looks like it's going from -5, -3, -1. It's a change of 2. So the most common mistake is that people sometimes think that our slope is 2. But remember, it's the change in Y always divided by change in X. If we're looking for our y-intercept, wouldn't our y-intercept be right here in between -1 and 1, where X is 0? So when we look for our y-intercept, it's when X equals 0. It's the Y value. So my Y value is equal to what number in that table? It would have to be, not 3. What would have to be between -2 and -4? -3. So my Y value should be -3. So my B, right, is -3. My M, the slope, was equal to 1. The B is equal to -3. When we write an equation in slope-intercept form, Y equals mx plus b. So my equation should be, so if you thought the last unit you were done with that, we're going to keep doing that. 1x minus 3. If we wanted to write it out as a sentence, this is how it might look. To find the output, I subtract 3 from the input. Please make sure you have both of those. In your homework tonight, to create a table for a function. Make an input and output table with the following function rule. Pick easy numbers and plug them in for your x values. What I always want you to do for your x values is pick at least 2 positives and 2 negatives. We're going to start with our negatives, so we're going to start with -2 for x, -1, 0, 1, and 2. Why are we picking those numbers? Because they're easy numbers to plug into this equation and replace my x value. When I look at that, if I replace this x the x in this equation with any of these numbers, it's pretty easy to solve. So if I am doing that, we are going to write right behind this, put equal. Move this underneath your desk so I can stand next to. So if we are looking at this, we're going to have 2 times. What is our x value that we are looking at? -2. So 2 times -2, keep writing, minus 4. If we multiply following our order of operations, right, we're going to have -4 minus 4, which gives us -8. Next one, plug in -1. 2 times -1 minus 4. -2 minus 4 is going to be equal to -6. We plug in 0. 2 times 0 minus 4. 2 times 0 is 0. Minus 4 is -4. How are these going up each time?
+2.
+2. That's what our slope was up here. M is 2, right? M is 2. What's our y-intercept? X is 0. It's negative 4. So this should be, I could use my formula again, but since this is linear, anytime it's linear, you should be able to continue with that rule, which in this case would be plugging in our numbers. 2 times 2 gives us 4, minus 4 gives us 0. Now, this table is going to come out a little differently when we look at our solution. So right behind here, again, let's pick those same numbers. Negative 2, negative 1, 0, 1, and 2. Behind the first one, please put it in a parenthesis, negative 2 squared plus 9. If I square negative 2, that means negative 2 times negative 2, I am going to get 4. Do you agree? Not negative 4. Negative times a negative gives me 4. 4 plus 9 is going to be equal to 13. When I plug in negative 1, put it in a parenthesis, because if you are using your calculator, you want to put it in a parenthesis also. Negative 1 times negative 1 gives us 1 plus 9 gives us 10. We're not squaring the 9, we're only squaring the 1. The next one is to take 0 squared. Oh, we like that, right? 0 squared plus 9 is just going to be 9. 1 squared, okay, so I put in 1 squared plus 9. 1 squared is 1 plus 9 is 10. When I plug in 2, what am I going to get for 2? 2 squared plus 9 should give us 13. So the question is, when we look at a function, we're going to be asked to decide if it is linear or not as we continue our lessons with this one. These are both functions. Each input gives us an output. Does it matter that 2 gives us 13 and negative 2 gives us 13? No. They both give us a unique outcome. Okay? So this one is going to be what we're going to talk about being linear. That second one is not. So I want you to look at this situation on that last page of your notes, which is on page 7. As you look at page 7, so please turn back to your notes on page 7, then you're going to do your homework later. It says you're going to hang out in an arcade with a friend for lunch. You have $16 in your pocket. You know you will spend $4 on food. Each game costs 50 cents. How many games can you play on after $4 of food? So, how many games could you play?
24.
Okay. Do you think it's possible to play, if we had 24 games, what would you be doing? How'd you figure out 24? I agree. You could have 24 games. How? I want you guys to come up with some other answers. Do you have to spend all your money? If you spend $24 on games, have you spent all your money? No. Yes, because you had, right? You had $16 in your pocket. You subtract 4 for food, so 16 minus 4 gave us $12 to spend. Each game is 50 cents. So 12 divided by, or 50 cents goes into 12. If you divide it by 2, I agree, 24 games. This person has spent all the money, right? Did you spend all the money? This person, yes. Would you have to spend all your money? So could I have only one game? My parents gave me the money and I now have $11.50 left, right? Could I get 10 games? Can I get more than 24 games? No, I cannot get more than 24. So it says, how many games can you play? We want to make a table. If you play 0 games, you've spent how much money?
0.
Food.
4.
4. 8 games. We spent 4 plus our original 4, which would give us $8. 16 games. Okay? That's $8 plus our original 4 would be 12, because we had 4 on food, right? So 4 for food, and then you have 8 for games, right? Okay, out of that $16 that we were talking about, input is 16. If we are looking at those, so we could have 8 games plus our food, and at 24 we would have spent all of our money, right? So when we are taking a look at this, please don't do that anymore, I'm going to have you leave. Our max we can play is up to 24 games, Could we play 23? Sure. Could we play 22? Any number up to that we could play. So it says, what is the domain? What are my inputs? Those are the amount of games I can play. I have anywhere from 0 up to how many games can I play? 0 to 24. So please write down my domain is going to be 0 to 24. And what that means, and this is where a lot of you lost points on the test, what it means. It means that you can play anywhere from 0 to 24 games. Some of you on the test, you didn't explain what your answer meant in terms of the problem. The range, the lowest range we can have is if we spend $4. The most games, if we play all the games, we're going to spend 16. So our range is 4 to 16. What does it mean in this problem? It means that when we look at that, we are spending anywhere from $4 to $16. So again, when I looked at your test, some of you didn't really explain it. You told me like slope, positive or negative, but you didn't tell me in terms of the problem. So your homework, if you turn to make a table, you need to use these values as your domain. So just like we did an XY table in your notes, you're going to put -2, -1, 0, 1, and 2. You're going to do the same for when you get to the next question, number 9, 10, 11. You're going to make an XY table. If you would prefer to make your XY table going across, that's okay, you could, because if you have more room. But what you need to do is plug those numbers in your calculator or solve. Make sure you're understanding how to do that. In this one, are we going to get some fractional answers as you look at question 11? Should I have fraction answers? Yeah, because I'm multiplying by a fourth. So I'm either going to have it as a fraction or a decimal when I take a look at that answer. Okay? So you have those 2 pages.